name is Janusz, and I will talk about benchmark, about DLIO, direct LiDAR inertial odometry algorithm that we have in our benchmark. So go to our website HDMapping. So once you go to browser and you type HDMapping, and if you follow let's say our project on GitHub, if you go to the section of the compatible or the state-of-the-art algorithms benchmark, then you find DLIO algorithm, this one. So just simply click this, then use hint and switch to the DVI data bunker data set. This is the branch you can see here. We have main and we have this bunker. This is for us important. And due to we have already done step 1, just to make experiment, just quick go to step 2. And you don't have to make this directory, but please keep in mind that we have some users that they don't, they are not so familiar with Linux. So just copy and paste all commands. So we create folder, we go to the folder, we clone the repository. Obviously you can study more what does it mean and how to use it, but at this moment more important is to run experiment rather than to know all details about it. So we check out to the bunker dataset and we build our Docker. So we have our DLIO algorithm, direct LiDAR inertial odometry. So in step 3, we go to folder with data. We change some parameters of the folder of the files, some accesses. Then we finally run our Docker, and this is the crucial moment. So you could see that we just copy and paste important steps, and now we have experiment. You can see that it is in ROS 1, robot operating system 1. This is unfortunately end of life. So let's observe how this algorithm performs. Sorry, we don't know yet it is well or not. So let's minimize this window. I don't know how to do that. Maybe like this. Okay, it will be on the left. Okay. So on the right side, I will show you dataset. So it will be this dataset. Okay. So what we expect, it is like this, or yes, it is like this. So you can see that our algorithm is trying to retrieve the geometry of the this dataset, this bunker dataset. So this dataset was created by my colleagues from Royal Military Academy and Ghent University. So you can see authors here, and I have to encourage them to improve the citation, so you can cite this dataset without any problem. And this dataset was collected with LiDAR, with active stereo camera, passive camera, and time of flight camera, and some IMU data. Thanks to this dataset, we can check how LiDAR inertial odometry algorithms perform in such demanding conditions, that we observe plenty of challenges like narrow passages, problem with changing lighting condition, and so on and so on. Why this dataset? Because it is also with ground truth. So we have this geodetic survey in this dataset, so we can easily compare with reality. It's very useful for quantitative and qualitative evaluation. Back to our project, because we are still calculating. We have some time to discuss project. So our project is HDMapping, and it is for people that would like to start adventure with mapping, mobile mapping. So once you have some mobile mapping device, or you can download data easily, then you have HDMapping LiDAR inertial odometry, you have LiDAR, you have HDMapping postgraph SLAM, and georeferencing. And those three tools are sufficient for creating city level maps. You can see some small part of it, small example. So let's back to our dataset. Okay, we are going back with dataset. We have already around 70% of the survey, and we are supporting in our project plenty of LiDARs. We are trying to support all of them. It's challenging, but we are trying hard, and we are trying to make a benchmark with all available LiDAR inertial odometry algorithms you can find in literature. We don't have access to the commercial one. It is very costly, and you have plenty of them, so we are rather focused on the state of the art. And what we have so far, we are making movies like this one. We are making movie of this one. Yes, we are making movie without direct LiDAR inertial odometry, and we have already 5. So I encourage you to study, to watch these movies, and to see how those algorithms perform in this dataset. Oh, we are in the middle, on the way back. You can see here, and this algorithm is recovering trajectory very well. This very nice result. Okay, so let's back to instruction. Maybe I lost instruction, or okay, I will recover again. So this is our instruction, and we will go to the step 4. We will open data in Cloud Compare. So I will introduce you a tool from our repository that we can convert results from this particular experiment, and we can export data to point cloud and trajectory for further qualitative and quantitative comparison and analysis. Okay, so we are almost in the end, so we will expect results here. We will expect that new folder here will appear. So you can see that all data is organized in such a folder. So you have see output of all algorithms, and now we are waiting for the DLIO. Okay, this one is our, it is already appeared, and you can see some files. For you, most significant is session.json, so you can open it with our tool. So our tool is multi-view TLS registration step 2, that you can open this session. You can open this session, and you have everything from that experiment in such a form that you can easily manipulate with this data with this tool. It can do much more than exporting, so please be encouraged to see what it can do. So we save all marked scan as a global scan. So we will have PC global.laz, and we save all trajectories in XYZ quaternion format. So so it will be useful for further analysis. Trajectory global.csv. Once we save our data, once we save, we have this point cloud and trajectory. Oh, yeah. So we can open it in Cloud Compare. And in Cloud Compare, you can, if you know Cloud Compare, you can manipulate this data as you wish. So we just drag and drop, and trajectory we can also drag and drop. You have XYZ coordinates, everything looks fine. So you can see the result, that it is already prepared for further manipulation. You can see point cloud, and you can see trajectory. So what we have so far, we have end-to-end experiment about DLIO algorithm. If you would like to find further information about this algorithm, just simply go to the main branch and simply click DLIO, and you have all information about algorithm that it is prepared from those autos. It is from 2023 in ICRA conference. Thank you for watching, and enjoy making your maps. See you soon.